Welcome to Drain Signal. You're watching DNS stuff. This is going to be a primer essentially on domain name service and how it fits in with Active Directory. So what you can expect from this video is that I'm going to throw a lot of vocabulary terms at you, then I'm going to take you on a couple of short tours of a DNS server. Now this is basically so that you have enough in your head for the certification exam. DNS is a huge topic area. So we're going to be focusing in on the basic core DNS stuff so you have a good understanding of it, as well as the stuff that has to do with Active Directory, okay? So in this video, we're going to be taking a quick overview of DNS. Then I'm going to talk to you about what DNS zones are. Then we're going to take a look at the different kinds of DNS records. We're going to talk briefly about forwarders and root hints and why you'd want to use one or the other. Then I'm going to talk to you about a brand new thing in Server 2008 called the Global Name Zone. Now, there's an old technology called WINS, which uses NetBIOS to do name resolution. And Global Name Zones is designed to help retire that old WINS service. And we'll get into that as well. All right, so let's go ahead and start off with a quick overview of domain name service. We've been really talking about it all throughout this course, kind of here and there, but let's really zero in on it for a little bit. Without DNS, if you have an Active Directory domain controller, it's worthless without DNS. Active Directory relies on DNS to do a huge amount of work, okay? Now, DNS is actually a Server 2008 role that's basically a big phone book. It allows users and computers to look up other computers and hosts, quote unquote, and that could be printers, PDAs, whatever other network devices might be out there. It helps us to find that host's IP address by using that host's name. Now, the process of locating a computer via an IP address by looking it up in DNS is what we call name resolution. So it's kind of a big fancy name for a pretty simplistic process, really. But when computers, or what we call hosts, get assigned IP addresses by DHCP, or maybe as an administrator you assign that IP address, they actually turn around and register their name and IP address with a DNS server. Now, you don't have to do this manually unless you really want to and you have extra time in your hands. But most of the time, we often will talk about dynamic domain servers maybe. Basically, all that means is that the process of registration with the domain name server is automatic. You don't have to put those records in manually, and that's a nice thing. And you know what? When we start to take a look at what happened inside of our DNS server all throughout while we were building the Globomantics and Verde Petra networks, you're going to see that there's a lot of stuff that happened that we didn't do anything with. It just all happened automatically. It's kind of a cool thing. Now, once that computer is registered with the DNS server, it can then be found by other computers through name resolution. Then that also allows Active Directory to find users, computers, hosts, printers, all that other stuff by working in conjunction with DNS. Again, without DNS, Active Directory isn't worth much. So you gotta have a DNS server to work with your Active Directory right alongside. Now, let's talk about some things that are inside of the DNS server. Okay, and I'm going to show these to you in just a few minutes, but I want to give you a quick introduction to them. A DNS zone basically is a text file, or it can also be, by the way, it's a database too, that defines what machines it knows about in the quote-unquote namespace. Now, when we're talking about namespace, we're talking about the nomenclature. We're talking about the naming scheme, if you will, for your particular domain. Now, there's 4 basic types of zones that you need to know about right out of the gate here. First of all, the one that's most recommended, especially now with Server 2008, is a thing called the Active Directory Integrated Zone. This is where the DNS database is actually stored in your Active Directory database file. It's actually stored in that ntds.dit file we've seen a couple times throughout this course. Now, if you have an Active Directory integrated zone, there's a lot of advantages to having that. None the list of which is that if you only have Active Directory integrated DNS servers all over the place, you don't need secondary zones, okay? Now, an Active Directory integrated zone also relies upon the fact that the machine that it lives on is also a domain controller, okay? So you're going to have multiple domain controllers out there if you want to have exclusively Active Directory integrated DNSs. Now, there's another type of zone that we used to see a lot more often, but as Active Directory integrated zones start to take center stage, we're going to start to see them kind of shift, I think. The primary zone is used in a standalone DNS server, okay? And it acts as a master DNS server that records information. All right, so think of the primary zone as a boss zone, okay? And the primary zone will oftentimes talk to and exchange information with a secondary zone. Now, a secondary zone is a read-only copy of a primary zone file. And what that means is that it has to copy zone files from a DNS server that has also a primary zone. We might take and put a DNS server that has only a secondary zone, maybe in like a branch office or something like that, where we would communicate with and copy stuff from a primary zone back at the main headquarters. Now, there's also what we call a stub zone. Okay? Now, a stub zone, we've talked about these already. We haven't really zeroed in real heavy on them, but a stub zone only contains information about other DNS servers. So in the instance where we were looking at Verde Petra communicating with Globomantics, in order to let those two networks know about each other, we created those stub zones on either side so that we could do name resolution across domains. That's what it's really all about, is being able to find stuff across domains. Now, by the way, there's another way to do it also called conditional forwarders. We briefly touched on that previously. We'll briefly touch on it again in this video. But let me talk to you a little bit about an Active Directory integrated zone and why this is a really good idea. Why Microsoft is recommending that we start to shift over to these Active Directory integrateds. First of all, let Active Directory manage a lot of the DNS stuff for you, okay? Stuff like zone transfers during AD replication. Let's say you have 4 different DNS servers that are all Active Directory integrated. They're all on domain controllers. Well, DNS information is exchanged during Active Directory replication as well. Now, you could schedule your DNS information to replicate at a different time if you wanted to, but you don't need to. Depending upon how much DNS information has actually changed since the last time you've had replication, since the domain controllers talked to each other and exchanged any new things that have happened in their particular section of the network. Multi-master replication, this is kind of a fancy word that tells us that multiple DNS servers can update all at the same time. The same thing goes with Active Directory replication as well. Secure dynamic updates. Now, this is a big deal, okay? When a change happens on a DNS server, that change, that dynamic update is secure. That communication is actually a secure communication. We don't want someone who's sniffing on our network to figure out what a particular name of a host machine is. Once an outside attacker has information about a particular host via the network, via the IP address or host name, then they have something to attack. But through secure dynamic updates, we're not exposing that information as we're transferring stuff back and forth. Backwards compatible with secondary zones. Now, if you have an older DNS secondary zone out on your network, it's no big deal. We can still use Active Directory zones along with those secondary zones if that's the case out there on your network. So we have a little bit of backwards compatibility there. So Active Directory integrated zones, a big deal, especially for small to medium organizations. I do want to put in a little bit of a caveat here, though. Depending upon the size of your network, the fact of the matter is that if you have a humongous network, you may not want to use an Active Directory integrated zone. For that matter, if you have a humongous network, there's a pretty good chance that you actually have a Unix or Linux DNS server out there. You might have several Unix and Linux DNS servers out there. That's just the way it goes. Active Directory can still work with Linux and Unix DNS servers. That's not a problem. Okay, I just want you to understand that. As long as the domain controller knows where and what the IP address of the primary DNS server is, we should be in pretty good shape. But I did just want to stop here and let you know that is out there, out in the networking world, especially in very large organizations. However, with small to medium organizations, having Active Directory integrated zones is perfectly fine. The reason why we may not want to have Active Directory integrated zones for very, very large networks, say, 250,000 users or something of that size, well, that's a lot of stuff to cram into an Active Directory database, especially when you're doing replication, especially when the servers are sharing information back and forth and pushing that information over the wire and sucking up your bandwidth. So I just wanted you to kind of be aware of that. But again, for small to medium organizations and even some large organizations, this is fine. All right. A couple more zones I want to talk to you about. We're going to see these here as soon as I'm done talking to you about the records. Forward lookup zones. Okay, a forward lookup zone actually hosts an IP address or looks up a host IP address by name. These are the most common zones that you're going to see out there. This is what everybody uses in order to find computers according to name. A reverse lookup zone, on the other hand, looks up a host name by IP address. Now, we use these mostly for security, okay? We use these mostly for error checking. We want to see if, in fact, for example, if in fact an email address actually did come from a particular network that it says it came from. All right, so using reverse lookup zones in a DNS server actually helps to verify and authenticate the identity of an email sender. So it's very useful, especially when you want to keep your email servers off of the spam lists. Stub zones, well, we've talked about these already. I want to bring them up again. But you remember these from when we used them in the Connecting the Continents video? Very, very useful whenever we're connecting to networks. Now, there's another way to do it, and what a lot of people would say is probably a little more efficient way. There's a thing called a conditional forwarder. And a conditional forwarder is basically used in place of a stub zone in order to forward DNS requests about other domains. So if we used a conditional forwarder instead of a stub zone, basically any information or any DNS requests about Verde Petra, let's say that, again, going back to our little picture, the little yellow hat man, remember that one? Instead of using information about how to find the DNS server for Verde Petra, instead, the conditional forwarder would just go ahead and throw it over there. We wouldn't even bother looking up the information. So conditional forwarder is a little more efficient, but there may be times when, conditional forwarder may not work. All right, so if that's the case, you can always use a stub zone instead. But conditional forwarders and stub zones, they basically do the same thing. It's just that conditional forwarders are a little more efficient, okay? All right, I'm going to talk to you about the DNS records, and then we're going to go over to our DC2 server in Globomantics that we built. I'm going to show you all the stuff that I've been talking about so you can see what it looks like. Now, first of all, what lives in a DNS zone? Well, we start off with A records. Now, an A record, also known as a host record, basically provides us with the name and IP address of a host. And that host might be a computer, might be a server, might be a network printer, a PDA, whatever. Anything that is on your network. If we need to be able to find it, we need to have a host record. Now, these are the records that get created for us automatically when a computer or a host, whatever that may be, registers with the DNS server. It says, hey, here's my name, here's my IP address, let other people find me. Now, a pointer record is actually kind of the exact opposite in terms of its format. A pointer record is a record in what we call the reverse lookup zone, and instead of having the name and IP address, it has the IP address and name, just in a different order, okay? And I'll show you what that'll look like here in just a minute. The start of authority. This is really the beginning record of a zone. It's a special record. Every zone has one of these. It basically defines a lot of stuff about the zone. Okay, and I'll show you what these look like as well. A serve record, these are for servers and service providing hosts. So servers that provide services like DNS or print services or any of the several other services that we have available to us in Server 2008 are going to have a serve record. All of our domain controllers, by the way, are going to have serve records. A name server record or NS record is just a record that points to a DNS server. Hey, that's a pretty simple one. But we also want to keep on track of all of the name servers, the DNS servers in our network as well. An MX record is for email servers. Okay, when we need to make sure our DNS server knows where to find the email servers, we use what we call an MX record, mail exchanger. And last but not least, before we get into our demo, a CNAME record is an alias. Okay, it's just a nickname record that allows for multiple names for the same machine. Okay, I know I've just thrown a huge amount of vocabulary at you and a huge amount of concepts. Now let's go ahead and let's go over to our server and let's start seeing where all this stuff lives at and what it looks like, okay? All right, so here we are over on NYDC2. Remember that this guy is our primary domain controller emulator. And we built this during the previous sections of our network all throughout. Let's go ahead and let's take a look, first of all, in our forward lookup zones, okay? Now, I wanted to point this first zone out to you. See this underscore msdcs.globalmantics.com zone here? This is an Active Directory integrated zone. How do I know that? Because it has the underscore msdcs in front of it. That's how I know. And that's how you know that this is an Active Directory integrated zone. Okay? Now let's take a look and see what's in here. First of all, we have our Start of Authority record. And our Start of Authority record contains information about the primary server, as you see here, the responsible person, when it gets refreshed, when it gets retried, how long does a request does it have to live. That's our TTL, by the way, time to live for this record. So it contains a lot of stuff about our DNS zone as a whole. Now here we have name server records, and I'm going to go ahead and pull over here just a little bit so you can see these name server records. Here we have a name server record for NADC1, DC2, NYDC3. See all these guys? These are all name servers. These are all DNS servers, or at least they contain DNS servers, I guess I probably should say. All right, so these are name server records. Then you see we also have CNAME records. We have aliases here, including one for our RODC that we built for NA and NY. Now, of course, we don't see anything from Verde Petra because that's not part of this namespace, right? Verde Petra has its own domain, its own naming scheme, its own namespace. Now, if we take a look here under this PDC, remember that PDC stands for Primary Domain Controller. Let's go ahead and let's take a look in here, and here's our TCP folder, and here we have a serve record, okay? See the serve record? This tells us that an LDAP, Lightweight Directory Access Protocol service, lives on NYDC2 2K8, okay? Here's the port number that it uses. So it gives us an idea here, at least a little bit about, we have at least the LDAP service running on NYDC2. All right, I'll tell that guy okay. So that's the service that is offered by this particular machine. Let's go ahead and minimize this one. Let's go into the global catalog. Let's see who is offering global catalog services to us. Now you see here that we do have some host records here already for global catalogs. You see we have 168.5.2, that's DC1, 0.3 is DC2, and 0.4 is DC3. Now if we go into the sites folder here, we have our Chicago site, we have a TCP folder. Here's LDAP services. And basically when you see LDAP services here, I want you to think about when users try to log on, they're actually looked up. Okay, they're actually looked up in the Active Directory domain database. And we use LDAP in order to make that happen. Okay? And again, LDAP stands for Lightweight Directory Access Protocol. Same thing for Dallas. We have an LDAP service running for Dallas and also for New York. And it looks like for New York, we have two of them running here, NYDC1 and NYDC2. Okay. If we go into domains, we can see similar stuff. Here's serve records for the domains, and for the domain controllers, here we have domain controller services. Here's a Kerberos authentication service being offered by DC3, DC2, and DC1. Okay. So those are serve records. Serve records are very important. And by the way, if any of these records are squirreled up, then that's going to cause disruption on your network. Right? I probably should just stop and mention here this to you, is that if there's a wrong IP address on any one of these records that I'm showing to you, let's say that somebody goes in and just wants to cause havoc and start switching around DNS records, putting in wrong IP addresses, maybe wrong host names, well then basically what that's going to do is disallow computers to find some of those other computers that have wrong DNS records, okay? Remember, DNS is all about the ability to find other computers. And the way that we do that is with these records that I'm showing to you here. Let's go into the Global Mantics forward lookup zone now. Now, this zone here is also contained in the Active Directory database. I just wanted to kind of show you these here. Again, we have the Start of Authority, name server records here. Here's a whole bunch of host records with all the computers we've been looking at and working on all throughout this video series. Here's our host records, and then we also have sites, which we've seen previously. Here we also have domain DNS zones and forest DNS zones too. And basically these folders contain information about which machines are considered to be part of this forest, which machines are considered to be part of this domain. Okay, I should point out to you here that here's an NA name server record. Let's take a look at this guy here. na.globalmatics.com even has a record. Notice that it's a name server record. It's pointing us to the DNS server that lives over in the na.globalmatics.com domain, which as you see is NADC1. So when you have child domains, you remember that, you know what? All of the stuff I'm showing you right now, we did not create on purpose, did we? I did not show you how to come in and create all these records by hand. You know why? Because I didn't have to. Okay? You didn't have to come in and create all of these records in DNS because it all happened for you. All of our machines, all of our services, all of the stuff happened automatically through dynamic DNS updates. All right, so enough about that. Let's go ahead and collapse our Global Matics forward lookup zone. Here is our Verde Petra stub zone that we created earlier. Remember when we created this one so that we could connect over to and trust our Verde Petra network? Well, here we have the start of authority, a name server, and then the host record for the DC. But notice it doesn't have anything else, right? It doesn't have anything else for Verde Petra. All it's going to tell us is where the name server is so we can go find it. That's it. All right, let's take a look at reverse lookup zones next. Now, a reverse lookup zone, I actually created this earlier. Okay, so this is one thing I created while you weren't looking, all right? But it's very, very easy. Notice that in reverse lookup zone, we still have start of authority records that define the authoritative zone here. We have name server records all down here, and then we have these pointer records. Now notice that in a pointer record, we start with the IP address, and then we have the name over here. Okay. Now if I go back over here to Global Matics, for a host record, notice I have the name, then the IP address. Okay. In reverse lookup zone, we have the IP address and then the name. Now again, the reverse lookup zone, for a small to medium network, you may not even need these, okay? It's not going to hurt you if you have them, though, too. Reverse lookup zones are very, very easy to create. It's like a three-step wizard. Now, I can't really show you how to create one because, well, it's already been created. But nevertheless, if you go to reverse lookup zone, you see nothing over here. You simply right-click on reverse lookup zone, you click on new zone, and this new zone wizard will pop up here. And you'll probably create a primary zone for the reverse lookup. You'll store the zone in Active Directory. You'll tell it how you want the zone to be replicated. Chances are you'll probably want it to be replicated to all servers in your whole forest. We'll tell it next, and then we tell it what kind of zone we're creating. We'll tell it next, and then we put in the network ID, which, by the way, is only the first 3 octets of your network address. Okay. And then we'll tell it next, and then you select allow only secure dynamic updates because that's what we want for Active Directory integrated zones. Okay, remember you don't get these whole dynamic secure updates without Active Directory. I'll tell it next, and now it's going to try to create this zone. Well, I can't really create it because it already exists. All right, so I'm just going to go ahead and cancel. But I did want to show you the wizard real quick just so you see that it's really easy to create. I mean, really super easy. All right, conditional forwarders. Conditional forwarders, remember, they basically serve the same purpose as the stub zone. A conditional forwarder just simply takes requests from one network that have to do with another network and forwards it over to the DNS server over on the other side. Now, I can create a new conditional forwarder here, at least I can try. It's probably going to be very angry with me because I already have a stub zone for this. Remember, you cannot have a stub zone and a conditional forwarder at the same time on the same machine, right? You might have a conditional forwarder on one machine, a stub zone on another machine, but you can't have both on the same machine. All right, now see, I'm just putting in the IP address of the DNS server for Verde Petra. All right, now it's going to try to resolve. It's going to be angry with me, and it's going to tell me that it can't because Verde Petra isn't actually turned on right now. I should probably just confess it to you right now. Verde Petra has been turned off to save some memory in the virtual machines. But if I try to create this zone right now, it's going to yell at me because I already have a stub zone for Verde Petra. And not to mention the fact that it can't find 192.168.5.200. That's not going to help either. So let's go ahead and cancel that guy out. So conditional forwarders are also very easy to create. The only reason why you're going to use conditional forwarders, though, or for that matter, stub zones, is if you have another domain that you're trying to communicate with. And I mean, or maybe even an additional forest that's altogether outside of your domain and outside of any namespace you currently have in your forest. All right, so there's the brief tour of DNS. Okay, so let's go ahead and let's bounce back on over to the servers. I want to talk to you now about forwarders and root hints and global names and a few other things. So let's go ahead and move back on over there and let's tackle that stuff. All right, forwarders and root hints. Okay, now forwarders act very similar to conditional forwarders, by the way, and so do root hints. Because here's the thing. If a DNS server doesn't know where a host is, it has to call to the outside world. Okay, now root hints and forwarders can allow us to do that. First of all, root hints allow your DNS server to communicate with name servers on the internet. That's what it does, okay? Without root hints, you will not be able to communicate with name servers necessarily. Now, I'm going to mention this to you is that a forwarder can act in the place of root hints if your security requirements are higher. Now, let me talk to you about this, what this means. A forwarder actually forwards requests over to another DNS server. Now, a forwarder usually acts inside of your own forest. Okay? Now, for this whole high security thing to work, you need two DNS servers for this. One on the inside of your network perimeter that doesn't use root hints, and one on the perimeter of your network, closest probably to your router. And I use close in the in the network term close. That does, okay? Internet DNS requests are going to be received by the inside server and forwarded out to the perimeter DNS server, and the perimeter DNS server is going to call out to the internet, get that information, bring it back, and then send it back over to the internal DNS server, okay? Now, forwarders can be very, very useful in a couple of different scenarios, but I just wanted to kind of bring this one up to you in case you find yourself in a very high security kind of environment. I'm going to take you back on over to the server now. I want to show you where the root hints are and where the forwarders are because they're in the same place, okay? All right, so back over here on DC2, here is the server. And I'm actually going to right-click on the DNS server here underneath DNS, and I'm going to go to Properties for it. And here is the Forwarders tab, okay? As you see here, there's actually a forwarder set up to go to NYDC1. All right, well, isn't that interesting? Forwarders are DNS servers that this server can use to resolve DNS queries for records that this server cannot resolve. So what does that mean? This means that if DC2 does not know anything about the request that's being made, it can call over to DC1 and let DC1 try to find it for us. Now look at this guy down here. Use root hints if no forwarders are available. Notice that this guy is currently unchecked. Now basically what this means is that right now this machine is actually going to talk to the outside world, and specifically the internet's name servers using NYDC1, or at least it would if NYDC1 was up and alive, which actually I think it is, to tell you the truth. But nevertheless, if this is not the case, if I want to allow this server, this DNS server, to be exposed to the outside world, to an internet name server, then I would put a check mark here, okay? This is oftentimes not the case. And notice that, you know what, I didn't set this up either, did I? All right, this is not something that I set up behind the scenes. This whole DNS thing was set up when we installed Active Directory domain services back in that very, third video? The third video in this series. So, I mean, it was a while back when we actually created this. Now, if I need to create additional forwarders for some reason, I can click here on Edit, and I could actually create new forwarders if need be. Okay, I don't need to right now, but I want to show you where it was just in case you find yourself in that situation. All right, root hints. Let me show you where the root hints are. Basically, these root hints allow us to go out to the outside world. Okay. Now, for some reason, you need to add in new root hints. If there's a root hint server out there that you need to add in, you can click here on Add, and you could actually add the new root hint in there. Most of the time, you're not going to touch this though. All right. Most of the time, you're going to let this as it is, unless you have very specific instructions on what root hint server that you're actually going to edit or add or remove. All right. So you generally are not going to mess with this unless you have a really, really good reason. Now you'll notice in here that it says root hints resolve queries for zones that do not exist on the local DNS server, i.e., what does that mean? Out there on the internet, out there in the public world. They are only used if forwarders are not configured or fail to respond. So if we don't have any forwarders over here to help us go find stuff that is not on our local network, well, we have no other choice but to find them in the root hints. That's it. All right, so I'm going to go ahead and tell this OK. And that kind of gives you at least a brief idea of where the root hints are and where forwarders are, where you can find those guys at. All right, back over to the slides, and let's talk about the last bit, global name zones. All right, global name zones. In the old days, we used to have a name resolution technology called WINS. And it's an older technology that allows us to use short names in order to resolve IP addresses, to look up IP addresses. Now, most WINS server technology is being replaced for DNS, primarily for reasons of speed, reliability, and security. All right, because WINS was not that secure, to say the least. Global name zones are a brand new feature of Server 2008 for what we now call single label name resolution. Now, the reason for this is really twofold, okay? You're going to use this for easy intranet websites. So if you have an intranet website you want to get to quickly and easily, you're going to use it. You're also going to use it as a potential replacement for WINS if you have older network-aware soft applications still running that require WINS. Now, if you're going to be rolling your network over to IP version 6, which a lot of people are in the next 5 to 10 years, you're going to want to try to include global name zones in your network design due to the fact that WINS is not supported in any form or shape at all in IP version 6. It is an IP version 4 technology only. So if you're going to go over to IP version 6 and you still have older software that relies on WINS, guess what? You're done with that software, okay? If it does not play nicely with the global name zone stuff, all right? WINS is still available on Server 2008. It's available as a feature, not a server role anymore. It used to be available as a server role. It's not now. If you try to use a global name zone in conjunction with one of your software applications that requires WINS and it doesn't work, well, don't freak out about it. You can still install WINS. However, just know that eventually that software that still requires WINS, it's going to have to be upgraded, or you're just going to be out of luck, all right? Or you just simply won't be able to use IP version 6, and that might be the case too. All right, so things to kind of keep in mind as we start to look towards the future here. In order to create a global name zone, it's pretty easy. First of all, on your primary DNS server, and this DNS server might be an Active Directory integrated zone server. It might be just a regular primary DNS zone server. Whatever it is, you're going to need to run this quick command. You're going to have to open up your command prompt, and you're going to type DNSCMD space /config space / enable global name support space 1. Okay? This little command enables the support in the DNS server for global names. All right? Then we create a new forward lookup zone called exactly what you see here on the screen, global names. Then you add CNAME records for any website or machine you want to have single label name resolution for. All right, so let me actually show you how this is done real quick, okay? All right, here we are back over on Server Manager. We're back on DC2. And we're going to go to the Start menu here. we're going to go to the command prompt. And first, we have to get our server ready by using DNS-CMD, which is just DNS command, space, config, space, slash, enable global names support, space 1. Let's see how I did. There we go. The registry property enable global name support was successfully reset. So this is actually something in the registry of your machine. All right, so we have enable global name support. That's fantastic. Now we're going to create a forward lookup zone. We're going to right click. We're going to create new zone. We'll create next. And we're going to be creating a primary zone. We will be storing it in Active Directory. We're going to tell it next. We'll have it replicated out to all DNS servers in the forest, or you may only want to have them replicated out to your one particular domain. In Globomantics, we'd probably have it replicated out to the entire forest, especially if it's a central web server or central server that requires single label name resolution. And now for the name, it has to be this. It has to be global names. Okay? It can't be anything else. You can't call it Bubba. You can't call it Spot. You can't call it Jill. You can't call it Doctor Who. You have to call it global names. All right? Tell it next. We're going to allow only secure dynamic updates and tell it next. And we're going to tell it finish. Now, just so you know, for global names, we probably didn't need to create the dynamic updates because you know what? In a global name zone, all that you really can do is you can really only come in here and create new CNAME records. And you have to create these all by hand. Okay? So let's say that I have a web server. And let's say I have this web server called Globomantics. Well, let's make it even more simple. Let's call it GWeb. Let's say that is what I want my users to be able to type into the address bar of Internet Explorer and get to the Globomantics intranet. Now, just so you know, in this network, this doesn't exist. I'm just creating this for an example. But let's say that the actual fully qualified name for it was Globomantics _ intranet 1.globomantics.com. Let's say that was the actual name of the actual machine. Do I want my users to type in Globomantics _ intranet 1.globomantics.com, or do I want them to be able to type in GWeb? Also, the same principle applies to servers or other hosts that require single name resolution for older software. You would put in the alias name or the NetBIOS name that software uses, and then you would put the fully qualified domain name down here in this box, okay? And we tell it okay. Now, obviously, this GWeb record isn't actually a real live record at this point. I'm just taking you through DNS concepts and giving you a shot in the arm, per se, for DNS stuff. In terms of the certification exam, anywhere, if you ever see a question that has anything to do with single name or single label name resolution, you are going to automatically think global names somewhere in the answer. Okay, that's just a little certification tip there from Coach. Now, you're going to see global names questions pop up probably all throughout the Server 2008 certification exam. I know I have. This is a big deal. Okay, so kind of keep that in the back of your mind. Global names equals single label name resolution. All right. Okay. Wow. I've just thrown a lot of stuff at you. You may have to come back and watch this video a couple times to catch all of it. Again, this is a short primer on DNS stuff. There's a lot more to it, but the stuff that I have given to you is going to be relatively vital for you to pass the exam. Okay, so I've basically given you the core exam topic coverage that you're probably going to see on the 7640. All right, so that's going to wrap this one up. We're going to move on to the next video that's going to start talking about public key infrastructure and certificate services. All right, so we're going to give you a primer on encryption and identity and all that good stuff coming up next.